In this session, let us start with problems on ZBus. Let us take the first sample problem. For the given 3-bus power system network shown, build ZBus. So here, in this network, we can observe that we have node 1, node 2, node 3, and then reference bus R. So obviously this will be a 3 cross 3 matrix finally. So ZBus will be 3 cross 3. Now here reference bus is R. In between reference bus and bus number 1, 0.25 is connected at one end, and between bus 2 and reference 0.25 is connected. Between 2 and 3.1, between 1 and 3.1, and between 1 and 2.1 is the impedance. Now coming to problems on ZBus, always we should begin with type 1 modification. Let us consider bus 1 and reference. So that is bus 1 and reference. Now we add the branch impedance between bus 1 and reference. So 1 and reference, which is 0.25. So new bus is 1, reference bus is R. So K is equal to 1, R is reference. So the applicable mathematical model is ZK is equal to ZA, K is equal to 0, ZK, K is equal to ZB. First formula here is not applicable because we don't have any old Z bus here. We're starting from scratch. So only ZK, K is equal to ZB will be applicable. So K is 1. So Z11 will be 0.25. The other one will not be applicable. So our Z bus now will contain one element, that is 0.25. So size is now 1 cross 1. As I had explained in the algorithm, when we do type 1 modification, size increases by 1. Earlier no matrix was there, now it is 1 cross 1. So it has increased by 1. Next, we'll be adding the impedance of the branch between buses 1 and 2. So as we can see here, between bus 1 and 2, 0.1 is there. So we are bringing in 0.1. So bus 2 is new bus now that is being introduced. Bus 1 was old bus that was already existing. So K is equal to 2, J is equal to 1 as per our notations. K is for new bus, J is for old bus. So the formula is Zk is equal to Zji, I varying from 1 to n, I not equal to K. Second formula Zk, K is equal to Zjj plus Zb. Over here, totally there are 3 buses in the network. So I can take the values 1, 2 and 3, out of which it cannot take the value of K, which is 2. When you substitute for I here, it can take only 1 and 3. And K is nothing but 2, J is 1. So if we substitute the same, we get Z21 is equal to Z11 in the first step, and Z23 is equal to Z13. Z23 is equal to Z13, but this will not be applicable because that is when we substitute I is equal to 3, it will not be applicable. This is because bus 3 has not yet been introduced in the network. So we have only Z21 is equal to Z11, and Z bus matrix is a symmetrical matrix. So Z21 is same as Z12. Already we have Z11 in our previous step, which is 0.25. So Z21 is equal to Z12 is equal to 0.25. Now going to the second formula, Zkk is equal to Zjj plus Zb. So substitute for K and J. Z22 is equal to Z11 plus Zb is the branch impedance that is being added in this step, which is 0.1, which will give us 0.25 plus 0.1, 0.35. Next, we'll write the ZBus matrix that we have got in this step. Since we have done type 2 modification, size will become 2 cross 2. It was 1 cross 1 in the previous step. So we just have to fill up the cell elements that we have got. We have got Z12, Z21, Z22. Z11 was already there in the previous step. So we have 0.25, 0.25, 0.25 and 0.35. Next, we will be now adding bus number 3, and the line connecting 1 and 3 is having an impedance of 0.1. So bus 3 will be new bus, bus 1 will be old bus. So type 2 modification will be repeated once again as we have done in the previous step. Same formulas, set of formulas will be applicable, but the variable is different. K will be 3 and J will be 1. Please follow these steps. Finally, we get Z bus is equal to 0.25, 0.25, 0.25, 0.25, 0.35, 0.25, 0.25, 0.25, and then 0.35. One more important thing to note, please be very careful when you're taking the value of I in the substitution here. I can take 1 to n, and n is nothing but 3 because 3 buses are there. So I can take 1, 2 and 3, but I should not take the value of k. So I should take only 1 and 2. So k and j values, if you substitute z31, see here in this step I am going to substitute I is equal to 1, j and k values in the first formula. So I have z31 is equal to z11, and since it is symmetric, it is also equal to z13. Similarly here, having substituting the values of k and j and I is equal to 2 in the first formula, we have z32 is equal to z12, which is also equal to z23 0.25, and then z second formula, zkk is equal to zjj plus zb, k and j if you substitute, you get z33 is equal to z11 plus 0.1, we get 0.35, and we write down the matrix. Next, in this step we'll be adding the transmission line having impedance 0.25 between 2 and reference, bus 2 and reference. Since it is involving bus 2, which is existing bus, treated as old bus, and reference, we are going to do type 3 modification here. So there won't be any change in dimension because we are including a link in the partial network. So here j is equal to 2, reference is r. The mathematical model is z bus new is equal to z bus old minus 1 over zjj plus zb, z1j up to znj, n being 3, z1j, z2j, z3j will be there. Here zj1, zj2, zj3 will be there. And now separately we take up this second term, simplify them, then we'll subtract from z bus old. See, z bus old is nothing but the z bus that we have got updated in the previous step. That is, this is our old z bus, and all other values that we fetch here from will be from this matrix itself. This is the updated z bus that we have as of now. So here, taking the second term, 1 over j is substituted as 2, so z22 plus zb is the branch impedance that we are adding in this step, which is 0.25, and we have z1j, that is j is 2, z12, z22, z32, z21, z22, z3, z23. Pick all these elements from the updated matrix that is obtained in the previous step. Pick all those values. Once it is done, uh, just simplify this, we get 0.104, 145, 104, 145, 204, 145, 104, 145, and 0.104. Now, to get this z bus, we have to subtract the second term that we have got from z bus old, that was our previous updated z bus. So z bus old minus this value will give us new z bus, that is this one. So this is now our updated z bus. So in our next step, wherever we need the elements of z bus, we pick it from this z bus. Now the last step is to add 0.1 impedance between buses 2 and 3. Now bus 2 and bus 3 both are old for us right now because already they have been introduced into the network earlier. So it becomes type 4 modification involving two old buses. So I is equal to 2, j is equal to 3, or you can take I is equal to 3, j is equal to 2. Both are same. Now this is the mathematical model for the type 4 modification. Z bus new is Z bus old minus 1 over ZB plus ZII plus ZJJ minus 2 ZIJ, Z1I minus Z1J up to the last term, that is n, and here ZI1 minus ZJ1 up to the last term. Here n is equal to 3 because in the system we have 3 buses. So Z1 I minus Z1J up to Z3I minus Z3J. Same thing here, ZI1 minus ZJ1 up to ZI3 minus ZJ3. Now here I and 2 values you just have to substitute. Again here also, in order to avoid mistakes, I'll calculate the second part first. So substitute ij values. So if that is done, you have, see, zb is nothing but 0.1 that was added, zii will be z22, z22 from where we have to get is from the previous updated z bus. Even zjj, which is z33, we have to pick it up from here, and then zij, which is z23, also has to be picked up from here, 0.105. All the elements have to be picked up from the previous updated matrix, and then multiply these two matrices divided by this term. See, this is the simplification part. Once it is done, we get this. So this finishes the calculation of the second part. So Z bus new can be obtained by subtracting the second term from the old Z bus. Old Z bus is our previous updated Z bus. Once it is subtracted, we get the final result: 0.1398, 0.1112, 0.125, 0.111, 0.1398, 0.125, 0.125, 0.126, and 0.1761. Since our network happens to be completed, just observe the problem. Uh, this is our network, so it is completed in this step. So we have added all the line impedances and all the buses. So this completes our Z bus formulation problem. Similarly, we go to the second problem. Build Z bus assuming bus 1 as reference for this given network. So bus 1 is reference, and we have bus 2, 3, 4. We can see the lines interconnecting the buses with given value of impedances: j.2, j.6, j.5, j.5, with in between the given buses. So as usual, we should start with type 1 modification. So I begin between bus 1 and bus 4, not necessarily between 1 and 4. You can also start from between 1 and 2 and go on. The approach that we follow can differ. See, there is no compulsion that we have to always start between 1 and 4. You can go between 1 and 2, 2, 3, 3, 4, or 1, 4, 1, 2, 2, 3. Any path can be taken. Only thing is, only the final answer is going to tally if the approach differs. The path that we take for building the Z bus, if it changes, final matrix will tally. Intermediate steps, the answer will not tally because the path would be different. So here I'm taking it between bus 1 and bus 4. So 1 is reference given in the problem, 4 is new bus introduced in step 1. So K will be equal to 4, R will be equal to 1. So as usual for type 1 modification, zk zik is equal to 0, as it will not be applicable since the network is new and we have added only one branch. Zkk is equal to zb will be applicable, so z44 will be equal to j.2. So you can clearly observe here our z bus matrix is j.2 having filled with cell number pertaining to fourth row and fourth column. Remaining will get added in the subsequent steps. So Z44 now is J.2. This is our Z bus. Step number 2, adding branch ZB between new and old bus. So what we are trying to do here is, I have introduced bus number 3. 1 and 4 was already drawn in the previous stage. Now I am bringing in bus number 3, and the line connecting 3 and 4 is having impedance of J.5. So here bus 3 is new, bus 4 was old, K is 3, which is new bus, 4, J is 4, which was old bus. So we have identified K and J values, and I'm just mentioning this is type 2 modification. Now the appropriate formula here is Zk is equal to Zji, where I take the values from 1 to n. See, in this problem there are 4 buses ultimately, so I can take the values of 1, 2, 3 and 4, and I should not take the value of k in the first formula. So again, reference should be omitted. So I'm not going to consider 1. At the same time, k value is 3. I'm not going to consider 3. So substitution of I should be only 2 and 4 in the first formula. K and J, however, are 3 and 4. So Zki is equal to Zji. In the first case, let us take I is equal to 2. When you take I is equal to 2, Z32 is equal to Z42, because K is 3, J is 4, I is 2. Z32 is equal to Z42. Since 32 is same as 23, it can be written as Z23. Then second formula, second case, taking I is equal to 4 in the first formula, we have Z34 is equal to Z44. Z34 is same as Z43. Then we'll go to the second formula, Zkk is equal to Zjj plus Zb, where Z33 is equal to Z44 plus J.5, which will give us 0.7J. So now you can observe that cell number 3 has been included in our Z bus. Previously we just had cell number with respect to fourth row, fourth column. Now third row, third column has come into picture. So now since we have carried out type 2 modification, size has increased by 1. Previous step it was 1 cross 1, now it has become 2 cross 2. So this is our updated Z bus. Step number 3, Next, we'll continue. I'll be bringing in bus 2 between, bus 2 will be introduced here, and the line connecting 2 and 3 having impedance j zero point 0.5. So bus 2 is new, bus 3 is old. So what is happening here is type 2 is getting repeated. K is 2, J is 3. So I don't have to repeat these steps. Same mathematical model gets repeated. Type 2 was done in the previous step. Same type 2 is getting repeated here. Only thing is the bus numbers are different. K is 2, J is 3. Substitutions will be different. So once this is done in detail, we get bus cell number 2, row number 2 and column filled up in this particular step. Please remember that Z33, Z34, Z43, Z44 is remaining as it is. Only thing is row and column with respect to 2, bus number 2 is getting filled up here over here. So we started with fourth element, then this was included, then this entire thing is included. So this completes step number 3. We are left out with one more line to be added between 1 and buses 1 and 2. So here bus 1 is reference, bus 2 is already existing, which is old. So when you are adding between old and reference, it becomes type 3 modification. Formula is z bus new is z bus old minus the second term, omit reference when you are considering z1j up to znj. So z1j will not be there because it becomes the reference. You will be having z2j, z3j and z4j. Here also zj1 will not be there, zj2, zj3, zj4 will be there. And this term zjj plus zb, if you substitute for j is equal to 2, because old bus is bus 2 is old, j is 2 and reference is 1, r is 1. So when that is substituted, you get 1.8 j. So second term is being calculated here. Substitute all the values, say z22, z32, z42, because it is z2j, z3j, z4j. Here it is zj2, zj3, zj4. So when j value is substituted, you get this. Pick all these elements from the updated z bus matrix that we have got here in the previous stage. Substitute all that, simplify, we get this answer 0.8j, 0.46, etc. Now the second term has to be subtracted from z bus old. Z bus old is again the updated matrix in the previous step. If that is subtracted, finally we get 0.4j, 0.23j, 0.07j, 0.24j, 0.43j, 0.123j, 0.07j, 0.123j and 0.179j. This completes our problem as the network is completely rebuilt. So this finishes the final Z bus matrix. Some more sample problems we'll see in the next video session.